All right, this is going to be our new unit, our start of the new unit over area. So this first couple of sections, we're going to go over area of just a few polygons, and then we'll move on to others. So this all should hopefully be reviewed from what you did in middle school already with area. So the first one I want to talk about is area of a rectangle. Again, you probably remember this from middle school. It's a pretty easy formula, base times height. Capital A is always going to represent area. Little b is the length of the base, and h is the height. Sometimes I know we call this length times width. So you can do length times width, which kind of represent the same thing. So if you want to write length times width, that'll work as well. So here we have a rectangle. I know it doesn't mark any right angles, but we're going to say opposite sides are congruent and have a right angle in there. You can call this the base and this the height. You can also call this the base and this the height. Oops. Okay, it doesn't matter which one you call the base and which one you call the height, because the base is always perpendicular to the height. Okay, all right, so that's a pretty easy one. The next one we're going to talk about is the area of the parallelogram, and this one also has the exact same formula, base times height. We don't really want to use length and width on this one because it's a little bit different. B is going to still represent the base, H is going to still represent the height, and of course the base and the height have to always be perpendicular. So I have a couple of different pictures of some parallelograms. This can be our base, which this dotted line right here is going to be our height. It can also be represented the other way. This cannot be your base. Don't always think the base has to be at the bottom. So in this case, the base can be the left or the right side, and then this will be our height in this case. And again, in both figures, you can see the base perpendicular to the height. Next one is the triangle. This one's going to be 1/2 base times height, and still the base is going to be perpendicular to the height. One thing that is kind of new, or that you didn't realize in middle school, is that any side can be represented by the base. It does not always have to be at the bottom. Okay, so this can be a base. So I'll just call this base 1, which the height that is perpendicular to base 1 is this one here. So that would be height 1. You can also consider another side being the base. So let's say this is the base over here, which I'll call base 2, which means this is going to be height number 2. And lastly, you can have another one represent the base, which this side is our last one. That can be a base. We'll call it base 3, which means this would be the height that goes along with that base. So it doesn't matter what side you use, okay? You just have to make sure that they are perpendicular. So over here we have ourselves a right triangle. This can be the base, and this is going to be the height. So it happens to be the sides of the right triangle. That's your base and that's your height. Remember, your base doesn't have to always be at the bottom. Now it could be, so if I had this as my base, well, you have to have a height coming from the opposite side, and it has to be perpendicular. So that can be a height as well, okay? All right. Let's try a couple of problems because I remember these being an issue in the past. So if I need to find the area of this triangle right here, you're probably thinking, well, which triangle? Because there's like 3 different triangles. Well, you want to find the area of the solid side of the triangle, the solid sides. These dotted lines out here, those are just to indicate other measures, but they're not part of the triangle. So I'm going to highlight the triangle that we need to find the area of, because this is a solid line, this is a solid line, and that's a solid line as well. So you don't want to find the area of anything else but that figure right there. So we know the base, which the base is only going to be, that's part of the triangle. So from here to here, that's going to be our base. It could have been the other side if we have other parts that were given to us, but this is the base because this is the only side that is shown to be perpendicular to the opposite side, which again is being extended, but this is the height out here. We don't even know what it is, but I do notice a right triangle, and so we can use our right triangle knowledge to find that. So notice this is an isosceles triangle, so this is going to be 12, and then I'm just going to do Pythagorean theorem to figure out h. So 12 squared minus 5 squared equals h squared. And then we're going to square root at the end to get rid of that. So let's put that in the calculator. I'm pretty sure that's a triple. I have a feeling it's going to be, but I'm not sure. So 12 squared, which is 144, minus 25 is 119. So it's not a triple. We'll square root that. And so the height is going to be about 10.91. Okay, meters. Now that we have the height, so now we're going to use our formula, 1/2 base times the height. Now the height is a long repeating decimal, so I'm just going to multiply it times what half of 12 is. And half of 12 is 6. So just to kind of keep it consistent in my calculator, so the area of this yellow triangle is 65.45 square meters. So we're now in squared units because square units is represented, is used to be representing area. Okay, so let's take a look over here using our area formulas. So I have 12 is AB, and I have BC is 5. Obviously not drawn to scale, and that's okay. Do not get disgruntled, just go with it, okay? If you want to redraw it, you can redraw it. So AB's 12, BC's 5, and they want to know what this is right here, okay? Well, in order to figure out that, and I have to find the area, well, I can find the area pretty easily because this is going to be our base and this is going to be our height. Why? Because the base and the height are perpendicular. And so it's going to be 1/2 5 times 12. And so half of 5 is 2.5, or half of 12 is 6, and 6 times 5 is 30. So this is 30 square inches. Okay, that's what those markings mean. So if you know the area and you want to try to figure out this right here, I said a second ago that this can be represented as the base or a different base, so we can say base 2, which means this can be represented as a height. I know how to find the base. I can use Pythagorean theorem to find the base. The two legs are 5 and 12, so I can do 5 squared plus 12 squared equals c squared, which 144 plus 25 is 169. And I square root that to get c by itself. The square root of that is a perfect square. So this whole entire base is 13. So I can do base times height and set it equal to 30, and that'll get me BD. Okay, so watch this over here. 1/2 base times height equals 30. And then I can just solve for h, which is the BD that they are wanting me to find. So half of 13 is 6.5. So 6.5 is equal to, 6.5 times h is equal to 30. So I just have to divide by 6.5 to both sides. So what is 30 divided by 6.5? 4.615 is going to be this height right here. So you can use the area to figure that out because, again, the base can be represented differently. So 4.615. Now, some of you are probably thinking, well, I see right triangles and I have some knowledge on how to solve for that by using trig. True, you can do that, but I just wanted to utilize area since that's what this unit is about. But yes, you can use trigonometry. All right, a little bit of area addition. So when we do area addition, this is going to be where you do the sum of the areas of non-overlapping parts of a certain region. Okay, and that'll be area addition. So it's basically when you add the areas of some figures to try to find the area. So on these grids right here, these are all going to be single unit grid lines. Okay, so meaning they have one unit in length. Okay, so like just 1 unit. And so as we look at this figure over here, it's kind of an odd shape, but you want to just utilize, make sure that you utilize different areas and use either rectangles or triangles or squares to find the area of each figure. Okay, so one thing that you kind of want to start with is see if how you can divide up the figure. So, and you want to work at the vertices. So if you get red, you can see it a little bit better. So if I come down from this vertex right here, and I go all the way to this vertex here, you see how I'm developing a right triangle? So I can find the area of this right triangle right here. The other thing that I can do is you want to go with this vertex here, there's another smaller right triangle. So I'm starting to see different regions and they don't overlap, and so I can work with that. Here's another vertex where I kind of want to come here. Probably all the way to this line, wide of that line, so I can get another right triangle like so. Okay. And you can leave this odd shape, or you can continue this straight down. So that way you have 2 rectangles, but they're pretty easy to find. So now that you've drawn it to each vertex to work out easily, these are easy rectangles. 1, 2, 3, 4, 5 is this, 3 is this. So the area of this little region is 15 square units. This is 3, and this is 1, 2, 3, another 5, so that's 15 also. Over here, when I do a triangle, these are right triangles, so this can be my base and this can be my height. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4. So this is 4 and this is 7. 4 times 7 divided by 2, or half of 4 times 7, same thing, is 14. So this area is 14. So I can do the same thing over here. 3, 4, 5, 6, 7, 8. So this is 8. 1, 2, 3, 4. This is 4. 8 and 4. And half of that is 16. So this is 16. Almost done. 1, 2, 3. 1, 2, 3, 4. 3 and 4 divided by 2. This is going to be 6. And the last one. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7, 8, 9. So let me double check, make sure I counted right. 1, 2, 3, 4, 5, 6. 2, 3, 4, 5, 6, 7, 8, 9. Yes, so 6 times 9 is 54. And 54 divided by 2 is 27. So I have 27, and I'm going to add all of these regions. 27 plus 6 plus 30 plus another 30, 93 square units. That's how you find the area of this. Okay, let's look at the triangle. Triangle's a little bit different. Now, I know what a lot of you guys are thinking. Let's draw in a height, something like this or something like this. They do not go perpendicular to the opposite side. And I always have a lot of kids that constantly want to do it that way. You don't want to do it this way. So here's the way to do this. Even some students have tried doing this like this. You don't know where this point is going to be. So how else is there a way to do this? Well, think the opposite of what we did before. We drew all the regions inside what if I think of doing them on the outside like this? So I can find the area of this whole entire rectangle, and this will be a perfect exact measure. If I find the area of this whole entire rectangle and then subtract these red right triangles on the outside, and that'll leave me with the area of the black triangle. So let's try it that way. So I've got 1, 2, 3, 4, 5, 7, 8, 9, 10. The width is 1, 2, 3, 4, 5, 6, 7, 8, 9, 14. Okay. So that whole thing is 140. So I'm going to take 140 units squared, and I'm going to subtract 3 different measures, this piece, and this piece, and that'll leave me with the triangle. So let's do these right triangles like I did over here on the left. 1, 2, 3, 4, 5, 6. 6 by 1, 2, 3, 4, 5, 6, 7, 8. 2, 3, 4, 5, 6, 7, 8. Okay, so 6 by 8. So 6 by 8. 6 times 8 divided by 2. So that's 48 divided by 2. 24. So this region is 24 square units. Okay, let's go to this one down here at the bottom. Well, I know the whole bottom is 14. 1, 2, 3, 4. 4. So 14 times 4 divided by 2. 56. 28. So this region is 28. So far I got the 140. I'm going to subtract 24 square units, 28, and then one more over here. So I know this side's 10. 3, 4, 5, 6. So this is 6 right here. So I'm going to do 6 times 10 divided by 2. That's a pretty easy number. 30. So I'm going to subtract 30. And there we go. It's a nice, perfect whole number because these all came out nice and whole. So 140 minus 24 minus 28 minus 30 leaves me with 58 square units. Okay, so sometimes you need to think outside that box. All right, let's go to area of a trapezoid. You guys did this in middle school also. Here's your formula: 1/2 base 1 plus base 2 times the height. And in this case, since there's 2 bases that we're using, both of those are always going to be perpendicular to 8. So I have 2 pictures here. Your basic trapezoid that looks like this. Okay, so this we can call base 1, this one we can call base 2, and your height can be anywhere from going from base 1 to base 2. It can be inside the triangle, it can be outside the triangle, it can be anywhere. So this can be the height and this can be the height, so long as it is perpendicular to both of those. Over here we have a little bit different trapezoid. This trapezoid, you'll notice that this bottom side is perpendicular to the left and the right, which forces these two to be parallel, which means this is going to be our base 1 and this is going to be our base 2. And therefore, this is the only piece that would be perpendicular to that, unless you can draw another one in too. That's fine as well. So either one of those. All right, we are also going to find the area of a kite in this section. So here's your formula for area of a kite, which this one is probably new to you. This one's going to be 1/2 times diagonal 1 times diagonal 2. So we're going to take half of diagonal 1 and diagonal 2 and just multiply them. And everything's just being multiplied here, guys. Okay, it's all being multiplied. Some of you guys get a little overboard with overthinking algebra and you want to distribute that 1/2. You do not want to distribute the 1/2. Okay. D1 and D2 stand for the lengths of your 2 diagonals, okay? So let's go ahead and label correctly. So we have 2 different kites here. This one's not marked, but this is a kite, okay? So the first diagonal that you can draw is from here all the way to the bottom. So we can call that diagonal 1, okay? And then the other one goes all the way from here to there. And you can call that diagonal 2. So it's the entire diagonal, and I know they intersect, and that's okay. This over here, you're probably thinking that's not a kite. It is a kite because you have two pairs of consecutive sides that are congruent. So the rhombus is a special kite because it falls under that same category of two sides, two consecutive sides being congruent. It just so happens they're all congruent. So you can still draw in your two diagonals. That can be diagonal 1, and the other one can be diagonal 2. Okay, now because it is a rhombus, you can still do your base times height because a rhombus is a parallelogram. So it depends on what's given in the situation. Okay, so you can use your diagonal formula or you can use your base times height formula. All right, so it depends what they give you, but I do want to show you that a kite can be used with the area of a rhombus and area of just a kite. All right, let's try this kite problem here. What's the area of this? Well, I do know that this diagonal here is 28. So we can say one diagonal is 28. I have no clue what the other one is, but I do know this side right here. So what do I need to do? You should know that that's a right triangle always, so you got to use Pythagorean theorem. So let's use Pythagorean theorem. 25 squared minus 20 squared equals a squared. And then we got a square root at the end. So 25 squared minus 20 squared equals to 25. That looks like it's going to be perfect. All right, so this is a perfect whole number, which means that's a triple. If this is 15, you have to remember your property that that is also 15, and therefore diagonal 2 is going to be your 30. So here's a quick, easy formula to use. It's going to be 1/2 times 28 times 30. You just put that in your calculator, and you should get about 420 square feet. That's what they are labeled. Okay, let's double check it one more time. Yes, 420. Okay, let's go and try different problem examples now. Find the area of the shaded region. Okay, so it looks like I have a parallelogram here, so I'm going to do base times height. Okay, everybody thinks that this is your base, which it is, which we don't have enough information down here, but if you look above, it is going to be 16. So our base is 16 and our height is that. So that's the area of the whole entire parallelogram. So basically, if I find the area of the parallelogram, then all I have to do is find the area of that shaded white area, which is what that looks like. Well, if opposite sides are parallel and these are different, then that means it's a trapezoid. So I'm going to take the parallelogram area and minus the trapezoid. Okay, so let's find the parallelogram first. Parallelogram is going to be 16 times 11 because the 11 of the height of the parallelogram is here. And then I'm going to minus the trapezoid, which is 1/2 base 1 plus base 2, which base 1 and base 2 are 9 and 3. And then the height of the trapezoid is 11 as well, okay, because that's perpendicular to the two bases. All right, so what is 16 times 11? 176 minus half of 12 is 6, and 6 times 11 is 66. So 176 minus 66 is 110 square feet. And there we go. So that's finding the area of the shaded region. You'll have some like this on your homework. All right, let's try a little bit different type of problem, a little bit of algebra. It says, what is the area of this figure here? I should have put a right angle here and say that these were rectangles. Okay, these are both going to be rectangles. And so we're going to just do length times width. So we're going to do x plus 4 times 2x plus 5. And that's going to be our area. Now we don't want to leave it like this. We want to simplify it out. So we're going to do the FOIL method. So x times 2x is 2x squared. The outside terms, x times 5 is 5x. The inside terms is, see, 8x, 4 times 2x. And these last terms right here are 4 times 5, which is 20. These are like terms, so you want to put those together. So the way you want to write your final answer, your area of this rectangle is going to be 2x squared plus 13x plus 20. Okay, let's try it again over here. I'm going to show you the other way instead of the FOIL. Sometimes you can divide it in the figure. I get a different color. But if you divide it like this and like this from here to here can be 5x squared, from here to here can be 3. This piece up here can be 6x, and this one can be -7. Okay, let me draw it a little bit better over here. 6x, -7, 5x squared, +3. And so you multiply basically length times width or base times height for each one. So this one's going to be 30x to the third. 6x times 3 is 18x. -7 times 5x is -35x squared. And -7 times 3 is -21. Okay, and you can see in all three boxes, you just want to write them all out. So 30x to the third, we'd have no like terms, minus 35x squared plus 18x minus 21. Okay, so that's doing a little bit of algebra with area. And lastly, a word problem. So you'll have some word problems too that involve area. It says Rashad wants to wallpaper the walls of his bedroom. His room measures 11 feet by 13 feet, and the ceiling is 10 feet high. A roll of paper measures 2.5 feet wide by 50 feet long. How many rolls should he buy? Okay, ignore any doors or windows. We'll leave that alone. So let's just say we're dealing with some rectangles. How many rectangles do you want to wallpaper? 4 rectangles, because he has 4 walls. Okay, we usually don't do the ceiling, and it doesn't say he wants to wallpaper the ceiling. So 4 walls. And so if you think of it, 3D, the 4 walls, these are all 10 feet high, and then it's 11 by 13. So you have one rectangle up here in the front that's 10 by 11, and it's 10 by 11 on this other wall. This wall over here is 10 by 13, and this wall over here is also 10 by 13. So you have 4 rectangles that you want to find the area for. That's what you need to do. Find the area of how much space we need to wallpaper. So we're doing 10 times 13, and we have 2 walls, so we're going to times that by 2. The other wall was 10 by 11, and we have 2 of those walls. So we're going to find those right there. So 10 times 13 is 130. 130 times 2 is 260. 10 times 11 is 110, and 110 times 2 is 220. You want to add that together, that's going to be 480 square feet that we need to wallpaper. Okay, so the question is how many rolls do we need? Well, one roll measures 2.5 feet wide by 50 feet long, so it's like one long rectangle. So what do we need to do there? We need to multiply 2.5 times 50 feet. So 2.5 times 50 is, I double check on my calculator, 125. So that's going to approximately cover 125 square feet. Okay. And so what do you do with those? You want to divide those two right there. So what is 480 divided by 125? And you always want to make sure you're in the same square units. If not, you have to do that before you find the area. So 480 divided by 125 is about 3.84. And so how many rolls does he need to buy? Well, you can't buy 0.84 of a roll. So you're going to take that up to 4 rolls. And that's it.